Okay, let's get started. Let's make sure that we're all in the right place. This is Math 1325. Obviously, it says it up there, a section. I'm going to leave it here in case someone walks in. They don't know where they are. Section 13. So this is Math for Business, the second section. So you should have already taken the Math 1324. Everybody in the right place? Okay, well, my name is Robert DiGiovanni, and I'm really only teaching this class because my schedule got messed up last semester, so I had to teach the 1324, and so I had a few students that wanted me to teach the 1325, so I went ahead and did that. Normally, I teach the calculus sequence, Cal 1, Cal 2, Cal 3, and then also pre-cal. So I'm actually excited about this class a little more than I was the 1324 because we're actually going to do calculus in this class. So that's, I'm excited for that. I'm not quite sure if you're excited for that. But you shouldn't be too freaked out. I mean, everyone talks about calculus being this big monster, which it is, but this is not a calculus class. This is, yes, it has calculus in it, but it in no way is like a normal calculus class. So don't go tell your friends you're taking calculus because you're taking kind of calculus, I guess, if that makes sense. We're gonna kind of make it easy because we want to be able to apply it to something, right? So we're going to be doing a lot of shortcuts, and we don't have to understand as much of the theory behind it. And not to mention, we will stay completely away from trigonometric functions, which is something that you take pre-calculus for. So, I mean, we are kind of on a watered-down version of calculus, but it's pretty exciting the things that we can do with it. All right, let's get a couple of administrative things out of the way. This is the course website. Everybody familiar with how to get to Canvas? Had anyone tried to get in here yet? It was not open, right? It opened up this morning. It opened up this morning. I know. I accidentally forgot to hit publish on the button, so it's open now, and I will give you some time to go through this and explore what's in here. The most important things for you to know are the syllabus is in here, and I will expect that you go through that syllabus, read it, make sure you understand all the requirements, especially because is there anyone here like this is your first college class ever? Shouldn't be. I mean, you should have taken 1324, which means that you have some experience in college, so you know how a syllabus works, and it's kind of our contract, yes? Is that safe to say? Okay, so I expect that you'll read the syllabus. I'm not going to take 40 minutes reading it, but I will point out a few things within the syllabus that are important. My office information is here for my office hours. If you need to come by and visit me, the hours are posted here when I'll be in my office. You can just come in and get help, okay? Also, my cell phone number, I provide my cell phone number to my students, and I encourage you, if you're ever having trouble with anything at home, to take a picture of the problem that you're working on, take a picture of the work you're working on, and text it to me. And then I have the ability to write on your pictures and send you back, you know, corrections. Or, oh, you know, put an arrow and say, hey, here's your mistake. And so that's available to you. You don't have to, but just know that you can, all right? Then there's just all this other blah, blah, blah stuff. Your grades are broken up by a daily grade. You're going to have 3 chapter exams and then a final exam. So daily grades can be pretty much anything. Quizzes, group works, take-home problems, whatever I tell you to do and bring back to me, I can count that as part of your daily grade. Attendance can be counted as part of daily grade. All right? Questions on that? Blah, blah, blah. Policies. Hold on. I should have my policy in here. There it is. So we got to get this out of the way. I do have, come on, stop. There we go. I do have an electronic device policy in terms of cell phones. So I don't want them out. I don't want you on your phone. I don't want you texting. I don't want you doing any of that in this classroom, okay? If there's something important that you need to take care of, you can step out of the classroom, take care of it, and come back in, all right? That clear? The penalty for having your phone out doing stuff not related to this course is 10% on your next exam. So that automatically takes you out of the possibility of getting an A on the next exam. And that's for each incident. So if you do it once, I'll take off 10. If you do it again, I'm gonna take 10 more. All right? Anyone wanna transfer into a different class yet? You all okay with that? Can everyone survive for an hour, 15 minutes without your phone? Okay. I have the same policy for behavior. I've never really had this issue, but I put it in here anyway. If you're sleeping in class or being disruptive in any way, then the same sort of thing, 10% off your next exam. We good? All right. This is the layout of what we're going to do, all right, in terms of our tentative schedule. Now, we're already behind one day, right, because we had that great winter storm of 2018. And so we weren't here on Tuesday, but we're still going to follow this. We're going to probably be a day off for a while, and then maybe we'll get caught up. But let's just see how things go. And you see, let's see, where's that exam? Their first exam isn't until late February. So quite a bit of material on that first exam. All right, and then exam 2 is going to be on the 22nd. So it's after spring break. So you get to go on spring break, and you get to like reformat your entire brain over spring break and then come back and have to take an exam, that next week. So try not to fry your brain completely over spring break. And then we have third exam, and then we have our final, okay? All right, so I'll let you go through that, the rest of that yourself. Any questions up to this point? Okay, so on this main page for the class, there are 2 very important links. And if you had me before, some of this is going to sound familiar, but some things are different. So the camera in the room is because I record everything I do up here is recorded, all right? Every day, I'll set up the camera, record the lecture. I'll post that on YouTube probably later today. I have a class right after this, so I can't do it right after class, but sometime today there will be a video there. So right now if you click on it, it's going to take you to a YouTube playlist, and it's going to be empty. There's nothing in here yet. But that's going to be this video, all right? So the idea behind that is there's 2 reasons for it. Number 1 is if you miss class, because you're allowed to have absences, okay? You just can't have excessive absences. If you miss class, you know that feeling when you come back and it feels like you're in a completely different classroom, like what happened while I was gone. Okay, you have the video to go to. So I would encourage you, if you miss class, to watch the video and then contact me if you have any questions, all right? So don't call me or text me or email me saying, hey, I missed class, what did we do? Because all I'm gonna tell you is go watch the video. That's what we did, right? So that's the first thing, is so that you don't ever feel like you're completely lost. And then the other thing is when I'm up here and we're going through things and we're trying to understand the concepts, that you can focus a little more attention on what's happening up here rather than trying to like write everything down and get it all on paper. So you know what I'm saying, where you're not really paying attention, you're just trying to get the notes down. Here you can actually pay a little more attention because you can always go back and rewatch it if you'd like. Okay, and then for the students that I've had before, I did not have this last semester. I normally do this for all my classes, and I think I'll be able to stay on track. I will have a link to your homework solutions. So like all your homework assignments that I give to you, you'll be able to click on this. And I already did your first 2 homeworks. I did them last week. So you can see the homework solutions for your day 1 review and for the day 2. The first 2, I'm going to give you 2 other sheets I'm going to hand out here. Those are going to be your homeworks. And if you have trouble on those, there's a video of me doing the entire assignment. So the idea here, again, is not so that you can just go like copy my answers down. It's so that the way it's supposed to work is you're supposed to sit there with your homework and try and work through a problem. And if you get stuck, you reference my video, you play a little bit of it until you're kind of on the same page with me, and then you pause it and you continue on your own, and then see if we line up. See if your work is matching up with mine, if your approach is the same as mine. Sitting there just watching the video and going, yeah, sure, I could do that. You know, that's danger zone right there. Because, you know, in math, you hopefully have learned this by now, that when you watch your instructor work through a problem, it's usually very easy for you to understand it because I'm not going to make the mistakes. Like, I know the path to go down. It's different when you're on your own and you don't have someone guiding you. So don't look at these videos as, oh, if I watch them and I understand them, I'm good. Use them more as a tool to help you through your homework. Does that make sense? And if I feel like these are being utilized, you know, by students, I'll continue them. But if I put up these videos and I see I only have like 2 views, you know, then I'm not sure it's worth the time that I have to put in to do the solutions. Yes?
You talk about the homework.
Yes.
Where's the homework going to be from? Like, you're going to give us a worksheet, or is there a book?
The homework is going to be out of the book, out of the textbook, which I brought with me. So in that, I don't know if you saw that schedule that I brought up, where it shows what we're doing every day. Yeah, okay, well, when I showed it up here, I don't know if you noticed to the side, there was a column that said what problems to do out of the book. Okay. So this is a book, and there's also, isn't there a paper version of this? Like a spiral version or something? No? Does anyone have something other than this?
I have them put in the paper version.
You have the paper version. So it's the same thing, right? It's the same thing, just cheaper, I guess, right? So that's where the homework will come from. Now, these first 2 videos that I did were actually off of a worksheet, which I'm going to give to you. But after that, after these 2 videos, everything else is going to come from this book. Any other questions? Okay. So I'll have your lecture videos and then the homework solution videos. Class files, inside class files is, I only have 2 things there right now. It's the schedule, which I would recommend you download and print. I think I already downloaded it. Wrong one. So here it is. I know you can't read that, but the date, the section we're covering in the book, the chapter section, the name, the topic, and then the page number from the book, and then the problems from the book. So I think you should just print that out and keep it with you. In fact, I've already printed my own copy, and I have it taped to a folder here, and when I go do my videos, I'm just going to break this out and start working off this. Okay, so I'll try and stay about a week ahead of the class in terms of those videos. Let's see here. And then the other really important document in here, and I'm not quite sure how this is going to work yet, is this packet. It's 87 pages, all right? I've handed out to you today, if there are any extra copies, please hand them to the students coming in here. I printed out the first 20 pages. Need a copy? Well, yes? I printed out the first 20 pages, which should get us pretty far through. I've got another one. Should get us through the first few weeks. But after that, after I get through these first 20 pages, I don't intend on printing them out anymore and giving them to you, unless we only have like 10 students left. If we have like 10 students left, maybe I'll print them out. I don't think that's going to happen though. So I'm going to project those pages up onto the board, but I'm not going to physically give you any copies after these first 20. And what these are classwork assignments that we're going to work, problems that we're going to work during class. All right, so you choose how you want to do that. And like I said, I haven't taught this class, so I'm not sure how I'm going to incorporate this yet in terms of, you know, do you need a paper copy? I'm not sure if you need it, but I figured day one, I'll give you at least the first 20 pages. And on these pages, if you don't mind looking at them real quick, you'll notice that it starts out, it's actually the second page. On the bottom it says page I, right? And then the back of that is well, 2, right? But notice that everything in there, those are all formulas. These are all formulas, and you can look at the first 5, let's see, 7, 8, 9, 10, 11. The first 12 pages of this document are the formulas and major ideas for the entire course. All right? So you can look at this almost like a formula, a set of formula sheets, okay? I don't believe I'm going to give you these on the test. I don't know yet. Let's see how things go. I don't know how much you're going to need to know for that first test, and if it's too many formulas, maybe I'll allow you to have these first 12 pages. But after those first 12, that's where you notice it changes and it says page 1, right, using normal numbers. Y'all see that? And that's actually what we're going to start working on today. And these are the classwork assignments. So there will be lecture, introduction to topics, and then we'll work through problems. Understand? Make sense? Okay. All right, so again, that is located, go back to your home page, it's under class files, that's where you can find that document. And then the schedule. Now I do have a syllabus confirmation quiz. It's supposed to be due tomorrow, right? Tomorrow's the 19th. Let's just see if you can get this done by tomorrow. All you do is you go into this website, you click on that, it's going to ask you basically yes or no that you understand the requirements of the course. And that's basically like you signing off on the syllabus. That way, when you break your cell phone out and you're sitting there updating your whatever's popular, I don't even know, I'm not going to claim to know. Instagram? Is that all right? Okay, so you're sitting there, you're updating your Instagram, whatever you're doing, right? And I take off 10 points and ask you to leave the classroom, and you're like, what? I'll go back to this and I'll say, look, you said you understood the requirements of the course, and the requirements say you can't be using your phone during class. Understand? So you're signing off on it. So let's see if you can get that done by tomorrow. All right? So that's your first real assignment. And then on this side, there's going to be like your grades, again, the files. This is basically the same link. And then there's a discussion board. There's your classmates. These two things, I may just take these out of here. I don't think they're very useful. No student has ever told me these are useful, so I might just take them out. It's like an online tutoring service that you can go use. It's free. And then there's a place where you can go and like join classmates in a virtual classroom and like use a whiteboard. Nobody's ever done it, but should I leave them there? No harm to just leave them there? Okay, I'll just leave them there. All right. Any questions? Pretty much, I'm ready to kind of dive in here. This quote here, I really like this quote. I put that on all my classes first entry page. I don't remember where I saw this, but don't practice till you get it right, practice till you can't get it wrong. So in mathematics, when you're doing your homework and when you're preparing for a test, if you sit there and you do a homework problem and you're like, yeah, I got it, you know, that is not enough. You need to get to a point where your comfort level is where you've practiced so much that you can't get it wrong. If you get 10 problems of the same type, you can't get it wrong. You know what I'm saying? It's almost like a mentality that, oh yeah, I finally got it right, I'm ready, versus give me a problem, I'm good. You know, I can handle it. I'm not afraid of the different variations you might give me. I'm comfortable with the idea. All right, so that's it. We're ready to start. I feel like you have something to say. Do you not have something to say? No? Y'all are so quiet. All right, so my theme this semester for all my classes, I spent the entire winter break, every waking moment of my winter break, thinking about what it was I wanted to really focus on this semester, and this is it right here. So I've been teaching for a long time at this college, and even though I haven't taught this class, I've seen something change in my students over these years, and this is the thing that I've seen. This is what's changed the most, is the work ethic of my students. You know, when I first started here, my students were eager, they were determined, and even if they failed trying, you know? And I think that I don't want to get into too much of a conversation or a lecture to you about my feelings on high schools these days, but let's just show of hands, how many of you are out of high school within the last 3 years? Okay, so all right, that's a majority, a strong majority of the class. Now, your experience in high school might be different than what I'm going to refer to here. I'm guessing that if you were in public school, you probably had test retakes. How many of you had test retakes? If you failed a test, you had an opportunity to retake a test. Okay, well, that is a problem. Okay, the problem is, the idea in high school is that, well, if the student fails it, then we relearn them, right? We reteach them, and then they have the opportunity to come back and show us they know. And what that does not teach students is this part, because students know that they're going to have that second opportunity. In fact, it's very difficult to not pass a math-based course, or any course for that matter, in high school. It's very difficult to be held back in a grade level. You know, in the old days, right, that was what motivated people to do well in school was, you know, you don't want to be that 16-year-old in 5th grade. You know what I'm saying? And so nowadays, there's this culture that's being developed in high schools where, you know what, you just show up and you're going to get through the class. Well, college is different, and there's no test retakes in this class, all right? You take that test that day, your performance on that test is going to determine a major portion of your grade. You must be prepared on that day. So because of that, you're going to have to make adjustments to your work ethic. Now, if you already have strong work ethic and you're determined and all that, you know, I'm not here to preach to you. It's just so we all have an understanding right now that my expectation is that when I assign a homework set, even though I'm not going to collect that, right? Even though I'm not going to collect that assignment and take it for a grade, that you're going to do that assignment. That's the expectation. There's no babysitter here. You know what I'm saying? I'm not going to come by and let me see all your homework. This is college. You're going to do the work because that's what it's going to take to get through the class. All right? So let's see how things go with this. I know nothing about a lot of you. There's a few students I know. I know what their work ethic's like kind of already. So, but everyone else, it's a blank page. You know, I'm not going to make any assumptions about your abilities or your work ethic. But I want you to understand that I am paying attention to this. So if you start coming to me after the first exam, you're not doing well, the first thing I'm going to ask you is, let me see your homework. You know, let's talk about how much time are you putting in. You know, are you working 40 hours a week right now? You know, I'm going to start seeing whether or not you've put too much on your plate. You know, because college is supposed to require a lot of time. That's why they call you full-time students. How many of you are full-time students? Okay, so how many? Okay, so those hands up again. Okay, those are all the full-time students. Keep your hand up if you work too. All right, so that's, again, a large part of you that are full-time students also work. That's a lot to put on your plate. Now, I did the same thing, so I understand you have to pay bills, right? But understand that the expectation here is the same. I'm not going to be like, oh, well, you work 40 hours a week, you know, like, you know, I'm going to hold you to a different standard than I'm going to hold anyone else in the class. It's going to be fair. Everyone's going to have the same expectation. All right, I'm done preaching. Let's get going. Today's review. All right, we're gonna do review, and I'm going to be working off of this handout, that page 1. Let me see if I can bring that up. Might be a little hard for you to see it up here, but you've got that copy in your hands, so that should be enough, you think? We good? All right. So today, there's really no like true lecture. I'm not going to like, hey, let's talk about this new concept, right? It's just going to be, let's do these problems. Let's see how comfortable we are with them. All right, first one. A company's profit increased linearly from $6 million at the end of year 1 to $14 million at the end of year 3. Part A, use the two data points, 1,6 and 3,14, to find the linear relationship y equals mx plus b between x equals year and y equals profit. Okay. Let's figure out first where these data points 1,6 and 3,14 came from. Where does 1,6 and 3,14 come from in the problem?
Year 1, 6 million.
Okay, so at year 1, the profit was 6 million, so that's right here in the word problem. Year 1, 6 million, that gave us our first data point. And then at the end of year 3, we had 14 million, so 314, right? So we have visually, graphically, we have 2 points. One, let's say 6, and then the other one is 3. And then I'll just extend this up, 14. Now my x-axis is what and my y-axis is what? In terms of the word problem, what are those quantities? The x-axis is the year. Okay, so I'm going to put x. I'm going to put years next to it. You don't need this graph. I just want us to understand what's going on here. Just make sure we're all on the same page. Y here is what? It's your profit, and does it tell you how it's measured here?
Millions.
Millions. So that's kind of important here, because when I put 6, I don't mean $6, do I? I mean $6 million, right? So I'm going to put here Y is dollars in millions. All right, that's what we have, right? And it's asking us to find the linear relationship y equals mx plus b. Everyone recognize y equals mx plus b? Okay? Between these two data points. So they want us to construct the line, right, between these 2 points. And more specifically, they want the equation of that line, right? Now, I did not extend the line all the way down. Why didn't I keep the line? Why didn't I bring the line backwards?
Zero profit.
Yeah, we're looking, this is 0, right? That would be at 0 years. So then we'd be going like negative years. May not make much sense within the word problem, right? So I'm just going to say this is my line, and it goes that way, all right? All right, so if we're going to come up with the equation of a line, y equals mx plus b, then what information do we need? What information is needed in order for us to be able to come up with that equation? We need the slope of the line, and then we need the y-intercept, right? So remember that this right here is the slope, and this is the y-intercept. Do we have the y-intercept of this line? Is it given to us? It's not, which means that we are not going to be able to use that formula just right off the bat. If we knew the y-intercept, couldn't we just plug that y-intercept right in here and then just go find m and we would be done? But because we don't have the y-intercept, we actually have to start with a different equation, not that one. So do you remember what equation we would use? Point slope, good, that's the name of it. The point slope equation of a line. And the point slope equation is y minus y1 equals m times x minus x1. Now let's see, is that on your formula sheets? It is? What page is that on? The first one. Wow, isn't that convenient? Look at that. First page, functions, linear functions, point slope form. It's on the left side there. Okay? So what is, this is going to, well, when would you use the point slope formula? If you have a point on the line and the slope of the line, right? That's kind of where the name comes from, right? If I have a point that's on the line and I have the slope of the line, then I can use this formula. Do I have a point on this line? Yes, I have actually two of them, but I can use either one. So I have a point, and then all I need is the slope. So we have not figured out what the slope is yet, but we can do that. I'll do that on the side. That's a different formula. To find the slope of a line, we use the formula y2 minus y1 over x2 minus x1. That is rise over run. And so I think it would be worth it for us to label our points. How about we label this point right here x1, y1, and we'll label this one x2, y2. Would it be okay if some other student wanted to kind of rebel and didn't want to follow the herd and be different, did x1, y1, and then x2, y2, would that be okay? Would that student be safe? Yes, it's okay. You can label the points however you want. Well, not however. It has to be x1, y1, can't be x1, y2. But you can choose this one to be x1, y1, that one to be x2, y2, or vice versa. We will all get the same result. So what were those points? We plotted them, but we didn't write them down. So this was the point 1, 6, and this was the point 3, 14, right? So this is going to hurt me. So what would our slope be? We're going to do what minus what on top? 14 minus 6 over 3 minus 1. And that's going to give us 8 over 2, which is 4. Right? 4 over 1, so that is our slope. Yep? Good? So we know this now, right? We know this part of the formula. Check on the M. And now all we need to do is plug in x1 and y1. And that will give us an equation. Now it's not the final answer, but it is the equation of the line. So I come in here and I write y minus, what's y1? 6 equals m, which was 4, times x minus x1, which was 1. So is this the equation of that line? Yes, it is. Now, is it the y equals mx plus b version of the line? No. So how do we get this to look like this? What do you have to do? You have to bring the 6 to the other side, and you have to distribute the 4 through. So I'm actually going to distribute the 4 first. All right? So even though that's a valid answer, my goal is to get it to look like this, because that's what they wanted, right? That's what you're being asked. So I'm going to distribute 4 through. When you distribute the 4, it's 4x minus 4. And then finally add 6 to both sides, and you get y is equal to 4x what? Plus 2. And this is the y equals mx plus b version of that linear relationship. All right, quick show of hands. How many of you felt really comfortable with that? You've seen that, you're good to go. Yes? Okay. If you felt uncomfortable, this is where you make a little note here like, what the heck am I doing in here? Like I've forgotten everything. And then maybe you come visit with me and we talk about, what it's going to take to get you up to speed. All right? All right, let's look. What does part B say? Is there a part B there? What is it asking?
Find the company's profit at the end of 2 years.
Okay, good. So find the company's profit at the end of 2 years. So what does that mean?
Plug 2 in for x.
Plug 2 in for x. Do you all agree? Yeah. So all you're going to do is plug 2 in for x into the equation we just came up with. And what would you get? 10? So I'm going to leave that equation right there because I'm going to be using it here. So find the company's profit at the end of 2 years. 2 years means that x is 2, right? Remember, x was the years, so that means x is 2. And so I go into my formula, y equals 4 times 2 plus 2, and that's going to give you 8 plus 2 is 10, but 10 what? $10 million. So however you want to write this. 10, you can put dollars in front of it and put million, like that. Since it's important to understand what that 10 represents, because yes, it is the number 10, but 10 what? 10 dogs? No, $10 million. Did y'all hear about that 20-year-old that hit the lottery? 20 years old, 258 million was what he got paid. He actually won the 500 million, but after taxes, that'd be a nice day, huh? 20 years old. Most of the time, it's some like retired person, right, who's like, only got about 10, 15 good years left on them, and they get all this money. 20 years old. That's kind of dangerous, though, don't you think? Okay, what about part C? Find the company's profit at the end of 5 years. So 5 years, X is 5. Okay, so same problem, same thing in here. Y equals 4 times 5 plus 2, so 22 million. All right, that's it. Moving on to new things. I forgot how bad these boards are. They don't erase very well. All right, calculate 4 to the 5th power. We should be able to do most of these problems without a calculator. Let's see. 4 to the 5th power. What does this mean? 4 times 4, 5 times, right? So this means 4 times 4 times 4 times 4 times 4. Maybe you do need a calculator. So let's talk about calculators. Like what's acceptable in here? Pretty much anything but a phone is acceptable. So you can get yourself a nice little scientific calculator, or you can get a graphing calculator. Just need to learn how to use it is the main thing. So if you have your calculator, bring it to class every day because we're going to need it, pretty much right off the bat. 4 to the 5th, everyone know how to type that in on your calculator? You can use that caret key. We call that the caret key. So 4 to the 5th power. 1024. 1024. How about negative 3 to the 6th? 729, is that what you said? Is it negative or positive? Negative? It's negative 729? Okay, I'm hearing negative and positive, so let's figure out which one it is. Let's take a vote. Negative 729? It's all right. Look, it's okay to be wrong. Who cares, right? No one's going to walk out of here and all, that guy. Right? Positive? Okay, what's going on here? We're taking negative 3 times itself 6 times, right? 1, 2, 3, 4, 5, 6. Okay, so let me do it this way. I'm putting in parentheses. A negative times a negative is positive. So these two are positive. Then this one would make it negative, and then positive, then negative, and then back to positive, right? So if you have an even number up here, and you're taking a negative number and raising it to an even power, you should always get a positive answer. Now, if you type that into your calculator and got negative 729, it's because you typed it in incorrectly. So if you go to your calculator right now and you just type in negative 3 raised to the 6th, it's going to give you negative 729. It's what it's going to give you, and it's wrong. Because what your calculator does is it treats this negative sign in the front like a negative 1. It treats it like this, negative 1 times 3 to the 6th. That's the way your calculator sees it when you type it in this way. So what your calculator does is order of operations, and it does it the correct way, which is to do exponents first. So it does 3 to the 6th, which is 729, and then it does multiplication. -1 times 729 would give you the negative. So your calculator didn't make the mistake. You typed it in incorrectly. To make the calculator do it right, you have to put this in parentheses. Then your calculator sees -3 to the 6th, and it will do this instead. Does that make sense? Sure? Okay, so the correct answer there is 729. That brings me back to like a classic question I ask all my students. What's the difference between these two? Like, what's the answer to this? 16? What's this?
That's 16.
This is 16?
Yes, it's negative.
This is -4 times -4, right? Because you're squaring the whole thing. This is -4 times -4, which is positive 16, right? This, without the parentheses, is exactly what I showed you here with what the calculator would do. This is actually -16 because you square the 4 first, which is 16, and then you make it negative. Do y'all see the difference? What I'm trying to show you is that parentheses are not there just for fun. I mean, we don't just be like, hey, this would look a lot better if I just threw parentheses. I just like the way that looks. It's important, right? It separates elements within the expression that either get squared or don't get squared. All right, let's move on to, how about that part C?
16.
So did you do that on your calculator? Yes? Okay, so you can do that on your calculator. If you do it on your calculator, you're going to need to type in 8 raised parentheses 4 divided by 3. That's how you would have to do it. Because it says you're going to take 8 and raise it to a fraction. But you have to have the fraction 4/3 in parentheses. If you type it in like this, without the parentheses, your calculator will do 8 to the 4th power first, and then divide that whole answer by 3. That's not the same answer. Okay? So what did you get? 16. Now there's another way to understand what that is without using a calculator, and that's to understand what a fractional power actually means. So let's see if this is on your formula sheet. Or I should say, we should see where it is. Look at page 1 again, and there's something here at the top under the exponents formulas, and it says this. See that? So we could use that with this. We could say that the x is the 8, and then the 4 is the m, and the 3 is the n, right? We could do that. And convert it over to a radical. So this would actually be what root out here?
Cube root.
Cube root, so 3, and then we would have 8 raised to the 4th power, like that. That's what that would mean. Now that still might be difficult to get because you would have to do 8 to the 4th power, which is a huge number, and then take the cube root. I think it might be difficult for people to see that the answer to that is 16. So let me show you something else. When you have this expression, you may also write it like this. So what's the difference between these two expressions?
It's going to multiply the cube root of 8 by 4, or in the, no, it's not, it's going to
Raise it,
to the
right,
power.
okay.
Yeah.
Yeah, so in this one, if you were going to do this one, you're going to do the 8 to the 4th power first, right? And then take the cube root. But you are allowed to, it is legal, to actually take that 4th power out and do it at the end. And do the cube root first, and then to the 4th power. And this is easier to do. Because what's the cube root of 8? 2, right? What number times itself 3 times gives you 8. So this inside is 2. So this becomes just 2 to the 4th power. And 2 to the 4th power, 2 times 2 times 2 is 16 times. It's 16, not 16 times. It's 16. So you get the same result. All right? I don't see that property on here. So what I'd like for you to do, you can add something to this if you'd like, where it says x to the m over n equals the nth root of x to the m. You can write next to that if you'd like. You don't have to do this. You can write the nth root of x, all of that to the m, because that's basically what I just did here. Okay? This, a lot of times, is harder to compute than this. A lot of times, this is easier to do. So this is the part I'd suggest you add. All right, we're moving on. We're multiplying. So how do you multiply that first expression in part A? You can use that thing called FOIL, right? Now, the correct technical word for that operation is not FOIL. It's called expanding the polynomials, or expanding. You can just say expanding. But FOIL is cute and everyone remembers it, so we can go with that. Okay, so you FOIL this out. You're going to multiply 2x times x, which would be what? 2x squared. And then you're going to multiply 2x times negative 4, negative 8x. Then the next middle or inside term there, 5x plus, right? 5x. And then final term, minus 20. Or negative 20, yeah. Okay, now one more step. Combine like terms. So you can put these two together. So you get 2x squared minus 3x minus 20, and we're done. We have multiplied the two together. What is the opposite of what we just did? Like if I asked you to go from here back to there, what is that called? Factoring, right? That's called factoring. So from here to here, expanding, going backwards is factoring. We're going to get some practice with factoring. All right. I think I'll leave part B to you. All right. You can do that on your own. I think y'all are okay with that. Let's move on to 4. All right. So this might look crazy to you. You're like, okay, I see a square root. I don't like square roots, whatever. But let's just look at what it's asking us to do. Evaluate f of 40, right? Is that what it says? Evaluate f of 40, which means what? What is this asking you to do? Plug 40 in to this function, replace the x with 40 right there. Then figure out what it is, right? So this means f of 40 means I'm going to take the square root. I replace that x with 40, so 40 minus 4. 40 minus 4 is 36. So square root of 36 is 6, isn't it? And we're done. This part, a little more challenging. Find the domain of f of x. What does that mean? What does domain mean? Anyone have a good way of explaining what domain is of a function? Go ahead. How do you mean? The x-axis in what way? Okay, so it has something to do with the x values. You're talking more in the graph. Would you be trying to say something like if you graphed it, it would be the x values where you actually have graph, right? That is one interpretation graphically of the domain. But without a graph, when we say find the domain and I give you a function or someone gives you a function, what are they asking you to determine?
Isn't the x-intercepts, or because I know that you can find it with that negative 4.
The negative 4 is definitely going to come into play here.
Is it either going to come out as a positive
Well, we can, if we use the graph, we can definitely get the domain by talking about where it's positive or something like that, or where the graph exists. But I'm trying to get us to think more abstractly. If somebody gives you a function, are we all comfortable with the idea that when you have a function like this, or like that one, functions take a number in and spit a number out? Right? Generally, that's what a function does, right? Give it an input, it has an output. So like if I plug in a number into this like 40, it's going to spit out the number 6. But with this function, am I allowed to plug in any number I want? Like, can I plug in 10? Can you do 10 minus 4? That's what, 6? Can you take the square root of 6? On your calculator, you probably could, right? Can you plug in 0? If you plug in 0, you're going to get -4 and then the square root of -4. And that's a problem, isn't it? We don't deal with square roots of negative numbers. You have to come and start talking about imaginary numbers, and that's beyond the scope of this class. So there are certain restrictions that we have to put on the x, right? The x's that we plug in are not just anything. And this, when you're saying find the domain, you're saying tell me what x's are allowed. All right? What x's are allowed into that function. So I already said 0 is not allowed, but what else isn't allowed? Yeah, I agree. Any negative number is not going to work there, right? But does that mean all the positive numbers work? No. Not all the positive numbers, right? 2 doesn't work. 2 minus 4 is still negative. Okay, so maybe x has to be bigger than 4? Okay, so look, we can start trying to like come up with it, right? But let's try and break down to something that's a little easier to handle. What can you not take the square root of? What can you not take the square root of? A negative number, right? Agreed? Okay, so what you really mean by that is that this expression underneath that root, right? X minus 4. You just told me that that expression cannot be negative, right? Which means it must be positive or 0, right? If you're telling me it can't be negative, that means it has to be greater than or equal to 0, doesn't it? So can't I just set that up and just write it down? I mean, this is what we need to happen, right? We need x minus 4, which is the expression underneath the root, to always be a positive number, which means bigger than 0, or possibly 0. Because what is the square root of 0? 0. Y'all following me? This is what we need to happen in order for that function to be able to deal with the input. Now this right here is called a linear inequality. And you did deal with those in the previous class. And to solve a linear inequality, it's relatively easy. You just isolate the variable. So we just add 4 to both sides. Okay, so if I add 4 to both sides, it's saying that x must be greater than or equal to 4. And that would be my domain. Now, I know in my 1324 class, we never ended with this. We always wrote our answer in interval notation. So let's try and write this same result in what we call interval notation. So think about it this way. If you have a number line, and here's 0, and here's 4, we want all our values, all our x's, to be bigger than or equal to 4, which means on which side of that 4? To the right of it. So any numbers over here will work. And what about 4 itself? 4 itself is allowed because we said equal. So you can either put a solid dot here, or I know in some classes they put a bracket there. It just depends on the class you took. Does this look familiar to most of you? Okay, so how do I represent all those answers to the right of 4 and including 4 in what's called interval notation? You put a bracket, and then you put 4, comma, and then everything out forever. Infinity. And then a parenthesis. You always put parenthesis on infinity. Why is there a bracket here?
I'm unable to answer your question.
Because you're including 4. If I did not want 4 in here, what would I have put instead of a bracket? Parenthesis. Okay? Does this kind of look familiar, interval notation? Now I'm going to add one more thing to this interval notation that I did not stress in my previous 1324 class. I'm going to add one thing to this. In front of this, I'm going to put X with this little symbol. That's the way I want the answer written. What this is saying is that the X, right, for this function, the X's must be an element of this interval. So look at that interval as being like a big pot. And what I'm saying here is that X has to be an element from within that pot of numbers. And then that function is well defined and good to go. This is the domain of the function. Got it? All right, let's look at 5a. So f of 40, this is a different function, isn't it? So we plug in 40, and you just get 1 over 34, right? When you plug 40 in. So that part's the part that really doesn't have a lot going on. Well, I need to pass around the sign-in sheet. I have a sheet here that you're supposed to initial next to your name every day. And I will for sure forget to hand this out, but I'll do my best to remember. Go ahead and initial next to your name. If your name's not on here, I left a couple of little slots here where you can put your name in. Initial for both Tuesday and today. All right, so domain-wise, remember how I said over here we needed x minus 4 to be bigger than or equal to 0? Can anybody out there tell me what I need to happen over here? Like what has to happen? Or you can also tell me what can't happen.
The denominator can't equal 0.
The denominator can't be 0. Everyone agree? So say that instead of using the word denominator, say it a different way.
X minus 6 is equal to 0?
Can't be equal.
Yeah.
Yep, okay, good. So x minus 6 cannot be equal to 0. Why? Because then you'd have division by 0, right? So this is a little different than this one because in this one we wrote down what we needed to happen, right? We needed x minus 4 to be bigger than or equal to 0. Over here, when we were talking about domain, we're actually telling you what we don't want it to be, right? We don't want x minus 6 to be 0. Now, that means that if you add 6 to both sides, that we don't want x to be 6. Right? But how are you going to write that answer in interval notation? Because I want your answers in interval notation.
It's going to be a union.
You're going to have 2 sets.
Infinity.
Okay, let me do it on a number line. Here's 0, right? That's just to give us a reference point. Here's 6, right? And we don't want 6. So if I don't want 6, I'm going to put an open hole there. And is it okay if we have everything to the left of 6? Yes? Forever, right? Is it okay if we have everything to the right of 6? Yes. Yes. So in interval notation, it's a little challenging to write this. It's kind of, this is nice and clean. X can't be 6. We know the answer. But to get this to interval notation, it requires a little more work. So how do I say everything to the left of 6, not including 6? So how do I write that in an interval? I'm talking about everything on this side. Parenthesis. Negative infinity. Comma 6.
And then another parenthesis.
Okay, why parenthesis and not bracket?
Because it's not equal.
You don't want 6, right? So the parenthesis leaves the 6 out. So that, do y'all see that this right here takes care of everything to the left of 6? Yes. Okay, now we need everything to the right of 6. So we're gonna have to put something in the middle here. This is where we use this symbol U, union. And then we write our second interval over here, which is going to be 6, comma, infinity. So that would be 6 and on. And so when you read this interval, it should be like reading a book from left to right. You're going to start out negative infinity, everything over there, all the way till you get to 6. You jump over 6, right? And then 6 on forever.